Okay guys, now I'm going to do the first part of task 17 for you on page 41 in your textbook. Alright, question 1a, 68 x to the power of 6 plus 128 x to the power of 6 under the same root. So what I'm going to do is just add them together. So when I add them together, it's going to be 196 x to the power of 6. 196 is a perfect square. It's 14 to the power of 2, right? And times x to the power of 6. So since it's a perfect square, we set 14 to the power of 2, which is 14 times 14, so that it will come out of the root as 14. X to the power of 6 will come out of the root as x to the power of 3. I just quickly want to remind you guys how we take the powers out of the root again. This is a square root, guys. Square root, we said the power of the root. When there is no power on the root, as you can see, like here, then it's a square root. So square root, the power of the root we accepted is 2. So all the powers inside the root will be divided by the power of the root, so which is 2, right? 2 divided by 2 will be 14 to the power of 1, which is 14. 6 divided by 2 will be 3, so it's going to be x to the power of 3. Right, question B. Okay, root 147 plus root 108. Guys, we just need to remember one of the rules for addition and subtraction. The number inside the root has to be the same. Otherwise, I can't do addition and subtraction. When I look at these numbers, they aren't the same. So I'm going to find the factors of these numbers. In this case, one of the factors, the one that will be staying in the root, must be the same for both. And one of those factors for each number must be perfect square so that it will come out of the root. Okay. So 147 is 3 times 49. 49 is perfect square, right? So it will come out as 7. 7 root 3. 3 will stay inside the root. And 108 is 3 times 36. 36 is a perfect square, so 36 will come out of the root as 6. This 3 will stay inside the root. So now the number that is in the root for both numbers is the same. Then I'm going to say simply 7 plus 6 will be 13. 13 root 3. Guys, once we get the number inside the root the same for both of them, we can't say root 3 plus root 3. The main thing is to get the number inside the root the same so that we can add the numbers. You see 7 plus 6 will be 13. Then the number inside the root will be the same, so I will keep it as is. Okay, so answer will be 13 root 3. Question C, root 27 minus root 48 divided by root 75. So obviously when I look at this question, guys, there are two rules, one for subtraction, one for division. I need to know both rules here. Okay, root 27 minus 48. Guys, again, the number inside the root is not the same, so I'm going to find the factors of these numbers, right? 27 is 3 times 9. 9 is a perfect square, so it's going to come out of the root as 3. This 3 here will stay inside the root, so it will be 3 root 3. Root 48 is 3 times 16. 16 will come out of the root as 4. This 3 here will stay inside the root. So once, as you can see, my number inside the root is the same, so I can do the subtraction. 3 minus 4 will be negative 1. So root 3, I'll keep it as is. So it's going to be negative 1 root 3, or because, guys, remember this 1 will be multiplied with this root 3. So if you say negative 1 times root 3 will be negative root 3. But I'm going to write this number so that you can see what is happening. Okay. Then at the bottom we have root 75. I'm going to find the factors of this also, so that is going to be, as you can see, I wrote it here, 25 times 3. 25 is a perfect square because 5 times 5 is 25, so it will come out of the root as 5. This 3 here will stay inside the root. Right, so the final loop will be like this, negative 1 root 3 for the top part of this fraction, and 5 root 3 for the bottom part of this fraction. So now root 3 divided by root 3 will be 1. Negative 1 divided by 5 will be negative 1 over 5. Guys, you can say root 3 divided by root 3, we said 1, right? So negative 1 times 1 will be obviously negative 1. So here 5 root 3 divided by root 3 again will be 1 for the bottom part. So 5 times 1 will be 5. Okay. So the answer will be negative 1 over 5. Okay, question D, it says root 90 times root 40 minus root 8 times root 18. Okay, so we just need to apply the broad mass rule here. First, we're going to do the multiplication and then the division. I'll just put the brackets here. You see the multiplication part, root 90 times root 40, and the minus root 8 times root 18. Guys, the separate roots can be written under the same root. So I'm going to this root 90 and root 40. I will just write them under the same root. So it's going to be 40 times 90, right? And then root 8 times root 18 also, I'll write them on the same root. So it's going to be 8 times 18. 40 times 90, again, still inside the root, 3 times 600 minus 8 times 18 will be 100 inside the root, 144. So 3,600 will come out of the root at 60 because it's perfect square. 60 times 60 will be 3,600. Right, so it comes out of the root as 60. 144 is also a perfect square because 12 to the power of 2 is 144. That's why it will come out of the root as 12. So 60 minus 12 will be 48. The answer will be 48. Then question E, it says root 20 minus root 5 divided by 4 root 5 minus 5 to the power of 1 over 2. Right, so you can see for the top part, first I'm going to top part or the bottom part, I need to do it separately, then I'll do the division there, right? So there's a subtraction here. The subtraction rule, we need to remember it, the number inside the root must be the same. So 20, again, I'm going to find the factors of this, right? So root 20 is 4 times 5 inside the root. So 4 is a perfect square, it will come out of the root as 2, so it's going to be 2 root 5. So root 20, guys, when I simplify it, it's going to be basically 2 root 5 minus root 5. Okay, 2 root 5 minus root 5. I'm going to check the bottom part, see here now what's happening. Okay, it's 4 root 5 minus 5 to the power of 1 over 2. Right, so when we look at this, guys, 5 to the power of 1 over 2, right? 5 to the power of 1 over 2 is basically root 5. Now, why? Okay, let's do this. Imagine now I'm taking this 5 out of the root. It's not a perfect square, so it won't come out of the root as a whole number, right? So remember we said when we're taking the numbers out of the root, we look at the power of the number inside the root. We divide that power by the power of the root. This is a square root, so the power of the root will be 2. Right? 5, it has no power. Remember, we can write every number as exponent if we add 1 to the power. So the first power of every number is the number itself. So if I write this 5 to the power of 1, right, instead of 5, and this is a square root, so the power of the root will be 2. Right? We said we divide the power inside the root, right, with the power of the root. So the power inside the root is 1. I'm going to divide that with the power of the root, which is 2. So it's going to come out as 5 to the power of 1 over 2. All right. But in this case, in this form, this number doesn't help me. So I will write it as root 5. Okay, so that I can do the subtraction here. Remember the subtraction, guys, the numbers inside the root must be the same. But if I write it 5 to the power of 1 over 2, it's not the same as this. So it must be the same as this. Okay, so I'm going to write as root 5. So it's going to be, right, we said here now, the final thing, 2 root 5, which is 4 root 20, minus root 5 equals to 1 root 5, or you can just say root 5. Okay, so 4 root 5 minus 5 to the power of 1 over 2, we said I'm going to write it as root 5. Okay, so now it's the same, I can do this subtraction. So 1 root 5, right, divided by 4 root 5 minus root 5 is going to be 3 root 5. Root 5 divided by root 5, this will cancel each other. It's going to be 1, so the answer is going to be 1 over 3. Cancel 1 over 3. Okay, question F, 2 root 50 plus root 2. Okay, so again, when I look at this, it's addition. I need to make the numbers inside the root the same, but it's here root 50 and root 2. So I'm going to find the factors of root 50. Right? Also, remember, guys, we said when we have a number in front of the root, So when I am taking any number out of the root, once I take it out of the root, I will multiply with the number in front of the root. Okay, just keep that also in mind. So inside the root, instead of 50, I'm going to write the factors 2 times 25. 25 is a perfect square, right? So it will come out of the root. It will come out of the root as 5. 5 times 2 will be 10. This 2 here will stay inside the root. So it's going to be 10 root 2. So basically, 2 root 50, guys, when we simplify it, it is going to be 10 root 2 plus root 2. As you can see, the number inside the root is the same. Root 2 plus 10 root 2 is going to be 11 root 2. Okay. Question G. 9 x to the power of 2 plus 16 x to the power of 2. Since it's under the same root, then I can simply do the addition, right? So 9 plus 16 will be 25, x to the power of 2, right? You see, once here, guys, it is just a simple exponent rule. So the exponents are the same. So I'm going to add the coefficients. So it's 9 plus 16 will be 25, x to the power of 2. Right, 25 will come out of the root as 5, x to the power of 2 will come out of the root as x. So 5 times x will be 5x. So the final answer is going to be 5x. All right, so now I'm going to do the second part of task 17.